In this video, we're going to still continue talking about topic 7.5, where we're doing Euler's method. This is example 2. So we have considered the differential equation dy dx equals x minus y with the initial condition y of 0 equals 1. We're going to use Euler's method with 4 equal step sizes to approximate y of 2. So we know that we know the beginning and we know the end. The question is asked a little differently. It tells us exactly how many steps we're supposed to have. So I know that I have to start with y of 0 equals 1, and I have to get all the way to y of 2. So I need to have 4 steps. So I'm going to try to figure that out. So I know that halfway in between would be y of 1. Okay, and again, we're approximately here. And then halfway in between these two would be y of 0.5. And then halfway in between these two would be y of 1.5. So you'll see that I have 1 step, 2 steps, 3 steps, 4 steps right there. So that's where I'm getting the step size of 4. All right, so again, we go back to the y value of the previous. So I'm going to go 1. And then I'm going to add that to, I have to take this and plug it into here. So I would have 0 minus 1, which is negative 1. So that's negative 1 there. And then I'm going to multiply by the step size, which our step size, we determined between here and here. So 1 minus 0.5, our step size is 0.5. Okay, so times 0.5. When I add that up, or multiply and add that up, I end up with 0.5. Okay, now we're going to repeat the process. I take the previous y value, so 0.5. I add that to, I'm going to look at, I'm going to take, not that number, I keep underlining the wrong thing. This one and this one. So I have 0.5 minus 0.5. That's my derivative, or my slope, which is going to be 0. And then I'm going to multiply by 0.5. So we've got 0 times 0.5 is 0, and then plus 0.5 would be 0.5. Okay, so it's not a hard process. It's just a little bit, it's tedious. We have to keep repeating it. So we're going to go ahead and I'm going to do 0.5 again, repeat the previous y value. Plus, and then I have to take this and this. So I'm going to go 1 and put it into here. 1 minus 0.5, which is going to be 0.5. So I've got 0.5 and then times my step size of 0.5. When I multiply that out and add it up, I get 0.75. Then I'm going to go one more round here. So this is repeat the previous y value. Then I've got to take the this, and they go into my derivative. So 1.5 minus 0.75 is going to be 0.75. And then I multiply that by the step size. And when I multiply that out and add that up, I get 1.125.